Derive the kinetic equation for rectilinear motion with uniform acceleration. First of all, consider our object is moving with constant acceleration from velocity v0 to v in time 0 to t. If we draw a graph of v versus t at t equal to 0 time, your velocity is v0. So we can say this length is v0, and at t time your velocity is v. So we will get this point. So we can say your graph will be linear. Now let's name the points. This is your A, B, C, D and O point. Clear? Now to get first equation of motion, we will use definition of acceleration, okay, which is rate of change of velocity. Now in this case, your velocity is changed from v0 to v, right? So we can say change in velocity is v minus v0 in time 0 to t. So change in time will be t minus 0. So here if we move a on the left side, we will get v minus v0 is equal to at, or we can say v equal to v0 plus at. This is your first equation of motion. Now for second equation of motion, we will use displacement in graph v versus t. We know that total distance covered in t time is area covered by graph. So that must be area of rectangle ACDO plus area of triangle ABC. So area of rectangle ACOD is actually product of their sides. So we'll get V0T plus, to get area of triangle ABC, we have half base, which is T, and altitude, which is BC, or we can say it is V minus V0. From equation A, we can say V minus V0 is AT. So here we will get V0T plus half T into AT, or we can say this will become AT square. So we can say here we get your second equation of motion. Now to get your last equation, we have to use distance. Your distance is nothing but average velocity into time t. Your average velocity is nothing but summation of velocity, which is v plus v0 by 2. And to get t, we are going to use equation A. We can make t subjective. So we'll get v minus v0 by a. So let's get it over here. For further simplification, we have to move this 2 and a on the left side. So we will get 2ax, and in numerator we have v plus v0 into v minus v0, which is nothing but v square minus v0 square. So here we get your third required equation. So these are your required equation of motion for uniform acceleration. Ta-da!